Assalamualaikum.
Walaikum
Walaikum
assalam.
assalam. Walaikum assalam.
Okay, welcome to the class of microwave engineering. Okay, so before I start today's lecture, any question from the last lecture?
No, sir.
Okay. Okay, so our topic that we are doing since the last two lectures is regarding impedance matching circuits. So I mentioned that there are number of networks available that you can use to solve the problem of impedance mismatching, which is an undesirable situation. So in our last lecture, we covered the working principle and design procedure of a network which was called as L network. Today we are going to move to the next type of impedance matching circuit known as stub matching network. So stub matching. And I already mentioned, but let me recapture about what we said about stub. So the stub word is used for a small section of a transmission line. Small section of a transmission line that is open circuited or short circuited. So we will find out how a transmission line can be used as an impedance matching circuit. But before talking about the use of transmission line as a matching network, we also need to understand the analytical explanation of a transmission line that is open circuit and short circuited. We have already covered that part, but let me do it again. So we covered two important cases of transmission line, that if there is a transmission line with characteristic impedance Z0, and assuming that it is a lossless piece of a transmission line, then its propagation constant will be represented by beta. And if the length of this transmission line is, let's say, small l, so if it is open circuited, it means that on the output of this transmission line, we don't connect anything between these two terminals. It means that ZL, load of this transmission line, is infinity, which we are calling as open circuited load. So open circuited load. So from our transmission line theory, we found that if you measure the impedance between the input terminals of this open circuited line, so if I represent the input impedance by this notation, which we have been using, so we have already proved this thing, that the input of this circuit will be equal to J Z0 tangent beta. So this is the behavior of any transmission line which is open circuited. Similarly, we also covered this part as well, that if we consider that the same transmission line piece with these properties, if you connect these two terminals of transmission line directly, it means just you connect them together. So it means as if load impedance is equal to 0. So you directly connect these two lines together with a small wire. So now this is a short circuited load. And now what will be the impedance between the input terminals of this line? So using the input impedance equation that we have covered in this course, from that equation, we will get this result. So this is something which we have covered before, but let's make use of that knowledge from impedance matching point of view. Now, what does this telling us? That this transmission line, its behavior in terms of impedance parameter is like this. And similarly, for a short circuited line, the behavior is like this. And what we are saying is that this circuit, which we are calling as stub, so this is a stub, as well as this circuit is also a stub. So what is the circuit behavior? So if you look at this equation, Jz naught tangent beta L, so it is clearly telling us that this stub, its behavior in terms of impedance is purely imaginary. Similarly, this is also purely imaginary. Or you can say it's the impedance is purely reactive. So I can say that this result means that the impedance is equal to J into reactance. Similarly, this result is telling us that the impedance is minus Jx. Okay. Now, the important point is how much is the value of this x. So x value is dependent on this value, on this parameter z naught tangent beta, and in this case, x value is will be equal to z naught cotangent beta. Now, what is the range of possible values? So x, which is equal to z naught, so z naught is a constant number. It can be 50 ohm, 100 ohm, or any value depending upon what is the characteristic impedance of the transmission line. So this z naught is fixed. Then we have a tangent function, and tangent function value will depend on beta times L. Beta is the phase constant. So this is also a constant parameter. So the only thing that is going to change is the length. How much is the length of this stub? How much is the length of this stub? So depending upon how much length you have selected, so this L will change. And as a result, tangent beta L will change and you will get a different value of X. But we know that tangent function, what is the range of tangent function? Again, question for you people. What is the range of tangent function?
0 to infinity, sir.
0 to infinity. Can anyone else confirm this answer? Tangent function range. Yes. Can you repeat?
Minus infinity.
Minus infinity to plus.
Yes, it's minus infinity to plus infinity. So it means this tangent, in our case, this theta is beta. So it means this value, this function, its value will also vary from minus infinity to plus infinity. So it means the value that you will get, x can be positive as well as negative. So let me write it over here. This number can be plus jx, it can also be minus jx. In a similar manner, Cotangent function, its range is also from minus infinity to plus infinity because cotangent is 1 over tangent. So minus infinity to plus infinity. It means that minus sign is because of the equation, but now we know that this function, when it becomes negative, so negative negative can make this positive as well. So there is a possibility that this impedance can be plus jx as well as it can be minus jx. So what is the overall behavior of both of these circuits, both of these stub? Input impedance of stub is going to give us this behavior, irrespective of whether it is an open circuited stub or whether it is a short circuited stub. Its impedance behavior is like this. So if you have a circuit or a component and its impedance behavior is like this, so what is this thing? What is this thing? What type of component impedance behavior is minus plus jx?
Reactive.
Yes, it is a reactive component. And what are those reactive components?
Capacitor.
Can you further specify?
Capacitive or
Capacitive
inductive?
Inductor. Yes, that is the answer. So it means this stub, the stub word that I'm using, which is basically a transmission line, from circuit point of view, we can use it as a capacitor or we can use it as an inductor. That is the basic working principle of a stub. When I will use a stub as an impedance matching circuit, so what type of role stub will play? It can act as a capacitor or as an inductor. So now you have another important concept of microwave engineering, that in addition to ordinary capacitors and inductors that you people are used to, even from your basic circuit theory courses, whenever you want to represent a capacitor, so you represent a capacitor like this, and then you have an inductor like this. So these are actual capacitors and inductors that you can buy from any electronic shop. But these are the capacitors and inductors that are used in normal circumstances at low frequencies. But now we know that even a transmission line, we can use it as a capacitor or inductor based on this whole discussion. And this is what we are going to be using in a stub matching network. So when I will be connecting a stub to my circuit, so I will be using the stub as an impedance matching circuit, but now you should know that what behavior stub is providing in the circuit. It is either acting as a capacitor or it is acting as an inductor. Okay. So based on this understanding, let's talk about the first stub matching network that we will cover in this course, and that is known as single stub matching network. Once we go through this, then we will also discuss another stub matching network, which is known as double stub matching network. So what is the circuit diagram of a single stub matching network? Once let me draw it, and then we will go through it step by step to find out how this stub is matching over circuit. So let's assume that this is the problem that we are facing, that there is a transmission line. This is our main transmission line or main system, and we have connected it with a load represented by ZL, and ZL is not equal to Z0. So this is telling us that our system is not matched. So we have to do something to rectify this problem. And the solution that we have selected is that we are going to match this load with the help of a single stub. So there are two possibilities. One possibility is that we can connect our stub uh, in parallel configuration, and that circuit will be known as shunt stub. So what is the possibility? We have two choices. One choice is at a certain distance from this load. So let's say we will find out what is the role of this parameter, but let me represent it with this notation d. What this d is representing? This d is the distance at which you will connect the stub from the load position. And then one possibility is that we can connect our stub in parallel. Okay, so what you will do, you will connect a piece of transmission line which is stub, one point connected with this point, and of course it is not connected over here, and the other terminal of the stub is connected at this point. And again, this end of the stub, we know it can be open circuited or it can also be short circuited. And this is going to be the length of our stub. So the first possibility that I have drawn, this type of circuit is known as shunt stub matching. So you already know that this shunt word is used for parallel connection. The other possibility is we can so let's assume that we have this load ZL not equal to Z naught. Then at a certain distance, I will break the main transmission line and I will connect my stub between these 2 points. So again, this is possible that this is either open circuited or short circuit. It is up to the microwave engineer to either use open circuit or short circuit. And I have already covered this part that both open circuit or short circuit stuff, they can give us this behavior. So again, there are two parameters of this. One is this distance, and the second parameter is the length of the stub. And this type of circuit is then known as series stub matching network. Series stub matching. So again, the difference, whether it is a series stub or shunt stub, it's right in front of you. when you connect stub parallel to the main transmission line, then it is a stub matching network. And when you connect the stub in series with the main transmission line, then it is known as series stub matching network. So what are the design parameters? So as a designer of stub matching network, what are important parameters that you need to find out? The first parameter is D, which is distance of stub, and our reference is load, so distance of stub from load position. And the second design parameter is L, small l, and what is small l? It is representing the length of the stub. Because how much should be the length of this stub? This is something that we will find out in a short while. So now, once you know the possible types of single stub matching network, the next thing is to find out the design process. How you will find out that for a given problem, which is right in front of you, for this problem for which ZL is given to you, Z naught will be given to you, and then you have this problem. So if you have selected stub as your impedance matching circuit, so you need to find out at which position I should connect my stub. And once you know the position, you need to find out what length of stub you need to select. Okay, so let's talk about this thing. So just like for the previous impedance matching network that we have covered in our previous lecture, that is L network, there are two possibilities. You can either design your circuit using equations. Just 1 minute. Okay, so there are two possibilities. We can design our single stub using analytical technique, and as before, we have an option of using Smith chart technique. Let me focus on this technique. I will briefly talk about analytical technique as well, because uh, this technique is not that much difficult, but people don't use it because as an engineer, you will always go for the simplest solution or simplest technique. So split chart technique is far easier than analytical technique, but that doesn't mean that you should not, you should be able to understand how to design single stub with the help of analytical technique. So I will briefly talk about analytical technique as well. But let me first focus on Smith chart technique. Before solving some particular problem, and then as I have asked you in the Google Classroom, that you must have a Smith chart in front of you. You must have a compass. You must have a ruler, so that whatever step I talk about, you should be doing that step along with this lecture. and that will make things easier for you later on. So make sure that you people have Smith chart. सबके पास Smith chart है?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Yes,
Okay.
sir.
Okay, that's good. Okay, so let me go back to, or let me just draw it again. What is, why these two parameters have importance in matching this circuit? So ultimate goal, why I am using single stub की stub मैंने use इसलिए किया है कि मेरा circuit match हो जाए. So let's find out कि इसमें D का और L का क्या role होगा. So let's consider this situation. So we have this problem that our system Z0 is not match over load, it not match with our load, and we are going to rectify this problem with the help of a stub. So as you move along this transmission line, so if I move from the load towards, of course, there will be source or generator connected to the left side of this transmission line. As I move on this transmission line, so at each and every point of this transmission line, impedance will be changing. We already know from our impedance equation that at each and every point, impedance is going to change. We need to find a point on this transmission line where we have this case that, let's assume that there is a point which I'm uh, representing with this dot. This, at this point, if I measure the impedance behavior is such that it's equal to Z0 minus plus Jx. What is the special thing about this point? At this point, the impedance real part is equal to the impedance that I want to match my load with. Imaginary part, which I have represented as either it can be plus Jx or it can be minus Jx. So minus plus mean that it doesn't matter. I am not right now. I'm not interested whether whether at this point the imaginary part is plus Jx or whether it is minus Jx. I am more interested what is the real part at of the impedance at this point, and what is the requirement? My requirement is that I need to find out a point where the real part is equal to Z0. And let's assume that this is the point. We will later talk about this thing, that how you will find out that point, but right now this is the point at which you will connect your stuff. So this is going to be D. So now I have explained what is the role of this parameter, or how you will find out where to connect the stuff. So now you have a principle that the point at which you will connect your stub, whether it is a series stub or a shunt stub, it doesn't matter. For both of these circuits, the concept is the same. What is the concept? The position of the stub. How you will find out where to connect the stub? You need to find out the point where you have this behavior. And what is that behavior? The real part of that point when you are going to connect your stub, its real part must be equal to Z0. Once you do that, the next thing we need to do is to cancel out this imaginary part. And how I will cancel out this part, that is with the help of a stub. That is with the help of stub, because we know stub can provide us either minus jx or it can also provide us plus jx. All we need to do is to adjust the length of our stub. So once we know, as an example, मैं इसको example के तौर पर ले रहा हूँ. Let's assume कि जिस point पे मैंने stub connect किया है, वहाँ पे situation ये है कि impedance is equal to z0 minus jx. And now I have to cancel out minus jx. How I will cancel out minus jx? If let's assume कि हम shunt stub को use कर रहे हैं, तो जिस जगह मैंने ये point mark किया हुआ है, अगर आप पैरेलल में यहाँ पे एक स्टब लगा दें और उसकी लेंथ को इस तरह एडजस्ट करें कि यहाँ पे ये आपको कितनी इम्पीडेंस प्रोवाइड करे, प्लस jx. अगेन ये ओपन सर्किट भी हो सकता है, ये शॉर्ट सर्किट भी हो सकता है. सो माइनस jx और प्लस jx जो है ये क्या हो जाएंगे, कैंसल आउट कर जाएंगे. तो इसका मतलब है कि अगर आप यहाँ पे इम्पीडेंस मेजर करें, कहाँ पे इम्पीडेंस मेजर करें, इस पॉइंट के लेफ्ट पे अगर आप इम्पीडेंस मेजर करें, सो इम्पीडेंस कितना होगा, it will be exactly equal to z0. So now, as before, if there is a wave coming from the source side, as soon as it arrives at this point, it will find out that impedance between these 2 points is z0. As a result, what will happen? There will be no reflection. So it will appear as if nothing is reflected. Nothing is reflected mean our circuit is matched. So let me write it down and then you can easily follow along. If there is any confusion, you can ask question. So what is the main point? Position of the stub requires finding a point on a transmission line where real part of the impedance is equal to z0. That is, z should be equal to z0, and as before, we can have either plus jx or minus jx. This is first point. And what is the second point? The imaginary part of impedance at that position is then cancelled by connecting a stub having appropriate length. That is, z is equal to if I'm using, let's say, अगर हम short circuit stub use कर रहे हैं तो z किसके बराबर था, j z0 tangent theta l. So इस part को cancel करने के लिए हमें क्या करना पड़ेगा, l को adjust करना पड़ेगा. So these are two important points about the working of single stub matching. Whether अगेन ऑलरेडी मैं कह चुका हूँ कि चाहे आप सीरीज स्टब की बात कर रहे हैं, शंट में, दोनों में डी का वही रोल है. अगर आप स्टब शंट में कनेक्ट कर रहे हैं सीरीज में, डी का कैसे हमें पता चलेगा, हमें डी के लिए फर्स्ट पॉइंट की तरफ आना पड़ेगा। हमें एक ऐसी पोजीशन फाइंड करनी है ट्रांसमिशन लाइन के ऊपर जहाँ पे ये बिहेवियर हमें मिलेगा, और ये बिहेवियर जब मिल जाएगा फिर हम क्या करेंगे, हमने इस नेगेटिव सॉरी इमेजिनरी पार्ट को कैंसिल आउट करना है। उसको कैंसिल कैसे करेंगे, उस पॉइंट पे जो जहाँ पे ये बिहेवियर हमें मिला है वहाँ पे हम स्टब लगाएंगे जिस तरह हमने यहाँ पे लगाया, और उस स्टब की फिर लेंथ को इस तरह एडजस्ट करेंगे कि यहाँ पे जो भी रियल पार्ट है, एज एन टू बी मोर कंक्रीट, अगर मेरे पास इस तरह का बिहेवियर है कि ये इक्वल है -J2 के बराबर है, तो स्टब की लेंथ मैं ऐसे एडजस्ट करूंगा कि मुझे +J2 प्रोवाइड करेगा। अगर यहाँ पे मुझे इस तरह का बिहेवियर मिल रहा है कि +J3 मिल रहा है, ये जो पार्ट है ये +J3 है, तो मैं स्टब की लेंथ को एडजस्ट करूंगा ताकि ये मुझे क्या प्रोवाइड करे, -J3 प्रोवाइड करे, ताकि हमारे पास सिर्फ ये रह जाए। ओके, again we are coming to the end of 40 minutes deadline, so I will continue with this lecture in the next session. I'm going to take a 10-minute break, so if you don't have any Smith chart or and the required tools, so make sure कि आप ये Smith chart और बाकी tools अपने सामने रख लें। later on जो जितना भी lecture है वो उसके लिए ज़रूरी है कि जो भी मैं आपको कहूँगा वो आपको draw करना पड़ेगा, and then I will be able to proceed further. Okay, so see you after 10 minutes. Okay.
Okay, sir.
Okay, sir.